So if we're going to go to our stat, edit, clear out your list if you have something in your list, or if you were on Desmos, that's fine too. So we're going to put 225, 300, 550, 200, 1000, 300, 280, and 100. And then we're going to hit, make sure you have 1, 2, 3, 4, 5, 6, 7, 8. That I'm sitting in slot 9, so that means I know I have 9, or I have 8 items in there. So stat, calc, and we're going to do one var stat. And we need our mean. So it's 307.5. The median's is 252.5 with the polar bear in there. So if you go to stat, and then you go to edit again, and we know polar bear is 1,000. That is a pretty good outlier there. If we delete it, oh, my numbers are not right. I just see one that's not right. Let's do that one more time. And go put the 1,000. Yep, 1,000's in there. So stat, count, one var stat. So it's 369.38. And then our median is 290 with polar bear in there. So then stat, edit, get rid of the 1,000. Then stat calc, one var stat. And our mean is now 279.29. So it did go down. The mean decreased. And the median is 280. So the median also decreased. So the mean decreases more than the median because the polar bear is a high outlier. So you need to know how much it decreased. So 270, so you want to do 369.38 minus 279.29. So it decreased, the mean decreased 90.09 with these numbers. And then the median decreased 10. I guess it actually increased, right? Because 280 is great. Negative 280 is, that's not negative. That's my little hash marks. There we go. Yeah. So it decreased 10 for your median. The mean decreases more because that's 90 than the median because it's a high outlier. So that's true. The mean decreases less than the median. That's not true because it decreased 90. The mean decreased more than the median because the high values balance the low value. No. And the mean decreases less, which again is no good. So the answer should be A. Is that not what we is that not what it said was the answer in the, I'm pretty sure that's what I put in there. Let me look at it though. Yeah, the answer is A. Because though 100 looks like a low maybe an outlier to these data points, if we know that our standard deviation is 138, as long as it's within 2 standard deviations, it's not an outlier. The other way we could look at it too is if we want to, just for future notice, you can second stat plot, cut our plot on. If we go to this box and whisker that has dots, watch this, show me that we're all wrong. Hold on, I gotta get rid of some math 3 stuff. Our X values are fine. We need to change our Y values, so go to Y or our window, and our Y minimum we got 100, so I'm gonna put 50. And our Y max, actually it's all X values, I'm sorry. Switch it back and forth between, so 50 to 1,200 is what I'm going to use. So the only outlier is that dot, and that's going to be that 1,000. If the 100 had been a dot, then you would have had an outlier on that end. So the low does not offset the high in that case, or the high doesn't offset the lows. They don't unbalance each other. Like when I take that guy out. So that's why it is A. This is an EOC release question, like literally straight from the packet as well, just for conversation's sakes. And so you know what to be expecting when it comes through. All right, so as far as inequalities and all that good fun stuff, Taylor, you said graph. Do you want individuals or systems? Because I have both. I printed both. And I have system of equation word problems too. And I have singular word problems as well. I mean, inequality word problems as well. So as far as just graphing, individuals. All right. Whoops, I lied. That was yesterday's or Tuesday's meeting. Sorry. So I have systems, but we'll do them separate. So we'll do each one. Like I'll do one here, and then we'll go back and add. So as long as they're in slope-intercept form, we're going to go to that positive 2. Why am I so crooked? All right, so positive 2 is our starting point. We have a slope of positive 2, which is 2 over 1. So up 2 over 1. Then we're going to go down 2 to the left 1 because that negative makes it a positive. And you do want to go the full extension of the graph. You're never going to have to actually graph these. You just have to be able to understand like solid line, dashed line, shade up, shade down, and things of that nature. So because this is a greater than or equal to, it's going to be a solid line. Which means any point that falls on that line is a solution. And because its y is greater than, that means you're having a good day at the fishing, as we talked about on a Tuesday, at fishing, you're having a great day, you're pulling up, and that's all relative to your y-axis. So that means greater than, you're going to shade this way for that one. So to do the same thing, this is greater than, so I'm going to do the second one. So y is less than 3x plus 2. So y is less than 3x plus 2. I'm trying to use another light color so they overlap. Okay. So positive 2. This is up 3 over 1, down 3 over 1, down 3 over 1, and then it's going to go off the graph. It's a less than, which means dashed or broken, just depending on where you, but not solid. So the points on this line are not part of the solution, and its y is less than. And the conversation we had earlier in the week is if you had a fishing boat and a fishing rod, and this is where your hook is, less than, you're having less than fun if you're not pulling that line out of the water with fish on it. So that's why you would shade down for less than, as far as just silly stories why. The mathematical reason why is this is the y-axis going this way is where you have your less than values. Though it looks like you're kind of shading to the right, it's all relative to which direction the smaller values on the y-axis are. Sorry, my brain hiccuped a little bit there. The other way you can also always try to decide where to check is I would use especially when the origin, because 0, 0 is pretty nice, and plug it in. So 0 is less than 3 times 0. So try test points, just like we did on the single number line before. So is 0 less than 2? That is a fact, so that means 0, 0 is a solution to that one inequality. So if we try it over here, 0 is greater than or equal to 2 times 0 plus 2. That's going to give me 0. So 0 is not greater than 2. So that's why that 0, 0 is not the direction you want to shade. Now, that is the exact same skill that you are going to now apply to systems. But the only difference is you're going to put 2 on 1. So we've graphed the first one. This one we're going to go down here to negative 1. We have a 1.5 slope, so up 1 over 2, up 1 over 2, down 1 to the left 2, down 1 to the left, oh, that was 2, down 1 to the left 2, down 1 to the left 2. Now, regular systems, if these were just lines, oops, and I'm messing up already. Getting excited. That is, there's no equal to, so that has to be a dashed line, not a solid line. So dash line, see if I get some white out here and dash this line up a little bit. So not a solid line. So any point that falls on that line is not a solution. If we were just doing linear, then our solution to the linear pair would be right here. But because it is inequalities, we know from here it's y is less than, so we're going to shade down the y-axis, which is this way. And again, you could plug in your 0. So 0 is less than 1/2 times 0 minus 1. Is 0 less than or negative 1? No, it's not. So you're shading away from 0, 0 again. With inequality systems, your solution, again, is still an overlap. It's this section where they overlap. So any coordinate within that overlap, and that does include, in this case, that solid line that's orange, but does not include the dashed line that's green. So it's the overlap. So if we're looking at number 5, we're going to do the same thing again. So we are going to the top one, so negative 2. And I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Hopefully yesterday's delta math with the shading and the lines sort of making themselves helped a little bit. This is a solid line because that is an equal to. It's greater than, so you're going to shade up. I'm trying to pick a color that if I put it with yellow, you're going to see a difference. I'm not sure. It's going to be a thing. So if I shade up, that's this way. And so again, your solution set is all of this overlap portion. So any coordinate over here will make both of those inequalities true. And in this case, that orange line here is a solid line, so those dots count, or anything in between. The dots on the green line do not count because they are dashed. When they are in standard form, you can either isolate y and put it in slope intercept form and then graph it. There's a call out in the video to the fact that you have to remember all your inequality rules and move everything across the equal marks, in this case is an inequality, appropriately, and don't lose any of your positive negatives. So another option to graph these very easily is use your intercepts. So x-intercept is what is the value of x when y is 0. Your y-intercept is what is the value of y when x is 0. And you can find that out easily by plugging in zeros. And I don't know about you, but I love plugging in zeros because it makes things go away. So for the first equation, we'll make it yellow. We'll do 4. We'll do our y-intercept first just because it comes first. So 4 times 0 is 0. Divide by negative 3. Now, when you know... divide by negative 3. When you divide by a negative, that's your golden rule of inequality. So that inequality has to flip because you divided by a negative. Remember, that's if you multiply or divide by a negative, the sign flips. So it gives me a negative 2. So it really doesn't matter. We're pretending that. So y is going to be negative 2 when x is 0. So when x is 0, y is going to be negative 2. And then we're going to solve for the x-intercept, which is 4x minus 3 times 0. And we can just put equal to 6 because we're just solving for that value, not necessarily the inequality part. These go away. So 4x equals 6. If we divide by 4, 6 divided by 4 is going to be 3 halves. So if I go over, that's 1 half, 2 halves, 3 halves. 1 1/2. So that means it went up to over 1 1/2. So up to over 1 1/2. Oops, that's only 1. 1 1/2 will be here. Up to over 1 1/2 should be here. Up to over 1 1/2. Whoops, I'm messing that up big time. See if I can make that better for you guys. 1 1/2 was not my ideal solution for this to be our first one. So 1 1/2 would be our intercept. So from this point to that point, it's up to over 1 1/2. So up to over 1 1/2. Up to over 1 1/2. The other way you can look at that slope very easily is from here. This is a good intersection. So it's 1, 2, 3, 4 over 3. So down 4 over 3 would be another good one. So down to over 1 1/2 would be your middle. Again, you can take that same equation. So 4x minus 3y is greater than 6. Move the 4x over. So negative 3y is greater than 6 minus 4x. Divide by negative 3. Remember, when you divide by negative 3 to flip that sign. It's going to be negative 2 plus 4 over 3x, and that's where that plus 4 over 3 is how we get to this point, and this point. Either way, you can graph that when it's in standard form. It is a greater than, so it's going to be a dashed line. It's greater than, which means it's going to go up. So we're going to go up from here on our y-axis, and up being that way. So we're going to shade in that direction. And then dealing with the second one, the second equation, get a blank sheet of paper so we can make plenty of space. That's x plus 3y is greater than or equal to 9. So you can move and put in slope-intercept form if you want to. So y is greater than or equal to 3 minus 1/3 x. Or again, we can solve for those intercepts. So x-intercept is what is x when y is 0. So we're going to put in a 0 for y. It doesn't matter. We're going to actually do plus. So x equals 9. So when y is 0, x equals 9. So it's 9, 0 for your x-intercept. So does it give us a graph good enough? It doesn't. Terrible. So you probably are going to be better off this way for this one. So positive 3, down 1 over 3, down 1 off the graph 3, up 1 over 3, up 1 over 3. And by all means, please don't freak out as far as the actual putting the line on the graph. It's more that you're going to be able to interpret the graph itself is how this is going to live on the EOC, or just identify, like pick a graph when given a system of inequalities. So making sure that you know that is the correct system that is graphed to the one that's given as the problem. So like a multiple choice style question would be what would be best. A best example of what you would be expected to do. And so again, I lost my highlighters. There it is. So your solution in this case is all up here. And it's the overlap again, not the individuals. So for x is greater than or equal to negative 3. So remember that Hoivux. So horizontal line is a y equals, vertical line is an x equals. So x is greater than or equal to negative 3. So we know when x is negative 3, which is right here, it has to be this way. It says greater than or equal to, so we can go ahead and connect and make that a straight line, solid line. And it says x is greater than. Now, in this case, we are looking at the x values. So that means we are going to shade to the right because x is greater than negative 3 going this way on the x-axis because it's an x equals or x's inequality equation. Because it is that vertical line, we're shading this way. And then from there, we're going to graph our next one. So again, this one would be one of the ones that a lot of us mess up when we isolate because you get rid of that negative and forget about it. Negative y is greater than negative 1 minus x because we move the x over. And then we have to divide by negative 1. Now, another way, which I will show you tomorrow, is to put these in Desmos. But you just have to be able to manipulate Desmos and know what to type in to make it do the inequality portion, the shaded portion. But it will do it as well because these are usually on the calculator active portion of the test. So positive 1, it's a positive 1-to-1 slope. It's a greater than, so it's a dashed line. And we did say greater than, so that means we're shading this way because it's on the y-axis going up, greater than. And your solutions are those that are in between this line here. So all the coordinates in that grayed out area. Unfortunately, 30 minutes doesn't go very long when we're doing stuff like this. So I have like 3 minutes. Do you want to hang in there for a minute and do a couple word problems? Or do you want me to show you how to graph word problems? Or do you want to call it a day and you work on work? I do have a couple more of these that I can just keep doing these if it's starting to make sense. You guys tell me what you want me to do. Because it's only 30 minutes and I want it to be your greatest benefit. All right, then. We'll just keep doing what we're doing. So y is less than or equal to 3. So we're going to go to positive 3 because Hoy bucks again. Horizontal is the y equals, so that means that line's going to go left and right at 3. And then y is less than, which means we're going to shade down from there. Because this is where all the y's are less than. And then we have the same equation again here. So that's x minus y is greater than negative 1. Move the x. Divide by negative 1. Y, because we divided by negative 1, we have to flip the sign. Oh, which we didn't do on the last one. Did anybody pick up on that? So that last one was wrong. Because I forgot the golden rule of inequalities. Because I'm trying to watch too many things at one time. So it should have flipped. Because we divided by that negative 1, that sign has to flip. So our last one was incorrect. It should have shaded in the other direction. Because the inequality changes. So in this case, we're going to graph from our 1. It's a positive line. So the line was graphed correctly on the previous. But it should have been shaded down because I forgot to switch our inequality when dividing by a negative. It's a dashed line because there's not an equal to there. And so we're going to shade down from here. So our solution sets are all the numbers that fall along the shaded, the overlap. So not the pink, not the purple, but the hot mess brown is where your answers for this system is. Okay, so it is 10:10, and I don't want anybody to run out on me, or I don't want anybody to quit listening to me, because this is very important. So if you have been like glazed over and out of it at the moment, because I know got a couple people that I'm not sure is always paying attention, and this is important. So ding, 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 pay attention, pay attention. So I did send out the survey to ask your opinions on when your availability is, and I spoke with the other teachers from Connect to find out when their availability is, because we are going to have a Math 1 EOC boot camp, and I say that because I know a couple people said no. I did it in Scotland County for 3 years, and we did it at Pinecrest for 2 years. And your EOC scores increase. Like, it's proven. It will be different because obviously we're virtual, and I can't sit there over your shoulder and touch things and hold things for you. And some of you don't have TI-84s or 83s, so that will make it a little different. But a lot of people's feedback was speaking to the anxiety of the EOC and just getting freaked out. I will say unanimously, almost unanimously, every person that attended the appropriate number of boot camps did not fear the EOC. And that is a huge deal. Like, if you can walk in there and not be panicked or freaked out, you will do 10 times better. The other really important part, so again, I'm going to say it one more time and sound really repetitive. Make sure you're listening to me. If you attend the correct number of EOC boot camps, you will get 10 points on your second 9 weeks average. 10 points on your average. That is the difference between a B and an A. All the way up to 99. I can't give you 100. I'll give you a 99. So if you had an 89, you'll get a 99. If you have a 93, you'll get a 99. But if you have a 53, you will get a 63. So for those of you who may have been struggling, which is usually not the guys showing up in here, but good to know our C's and B's could turn into A's quite easily if you show up to the boot camp and do what's expected of you there. We are going to work problems. It will probably be 45 minutes to an hour. And then we have to, because administration says I have to, you'll have to either fill in like a Kahoot or a Quizlet or something with what I'm thinking are going to be either the exact same questions or the same question with different numbers towards the back end of it. But in the beginning, it'll probably be the exact same questions we go over. It will not be recorded and posted. So if you miss it, then you miss it. And you do not get credit for attendance that day just by doing the Quizlet or the Kahoot. You have to actually show up. And I will probably have to hear your voice. I'm still working on that part because not everyone's super hyped on it. But I love the idea that if you show up to enough of them, and it's probably going to be like 7 out of 14 scheduled, and the schedule will come out on Friday. So just some insider gossip news going on for Math 1, so you guys know. All right, guys. Have a fantastic afternoon. Happy Baby Friday. I'm thinking next week because I'm trying to make sure we have enough of them that if there's a schedule conflict, you can make it to 7. Does that make sense? Like I'm gonna schedule like 12 or 14, and you just have to make it to. And I think the number's 7. So don't quote me on the number part because I still have to make sure that everybody in like other teachers and principals okay with what I make the decision. I have to send it to him first before I can send it out to y'all. All right, perfect. Have a great afternoon. Jakai, how you doing, baby? Did you hear all that good stuff? Could be a game changer.